A planet the size of 11 Earths suddenly started looking wrong, and nobody had an explanation fast enough to make sense of it. In early 2010, astronomers turned their telescopes toward Jupiter and saw something impossible. One of its most recognizable dark atmospheric bands had vanished so completely that the planet itself looked visually broken. The famous South Equatorial Belt, a permanent stripe stretching wider than Earth, had simply disappeared. And the worst part was not what vanished. It was what that disappearance revealed about everything scientists thought they understood. For decades, Jupiter had been treated as one of the most predictable atmospheric laboratories in the solar system. Its colored cloud bands looked stable, reliable, permanent enough that astronomers used them almost like fingerprints. The South Equatorial Belt was one of the planet's defining features, a massive dark brown band created by powerful jet streams circling the entire globe at hundreds of miles per hour. Models suggested these systems were locked into long-term equilibrium. Giant gas planets were supposed to change slowly. Then, over just a few weeks, that confidence began collapsing. Amateur astronomers noticed it first. Night after night, images arriving from backyard observatories looked increasingly strange. The dark belt seemed to fade a little more each time. At first, people suspected equipment error, telescope calibration problems, atmospheric distortion from Earth, but then larger observatories confirmed the same disturbing image. The entire southern hemisphere of Jupiter was brightening. The dark stripe was being erased in real time. And suddenly, every existing atmospheric prediction was no longer matching what telescopes were seeing. That visual contradiction mattered more than it seemed. Jupiter's atmosphere is not like weather on Earth. There is no solid ground underneath driving pressure systems. The entire visible planet is a constantly shifting ocean of gas, extending thousands of miles downward. Scientists believe the dark cloud belts represented deep circulation systems carrying warmer material upward while lighter ammonia clouds remained suspended above. If one of those belts disappeared, it meant a planetary system larger than Earth had shut itself down without warning. And existing models predicted no mechanism capable of doing that. At first, researchers thought the answer was simple. Maybe the belt had not vanished at all. Maybe upper cloud layers had thickened and temporarily hidden the darker material below. That explanation fit known chemistry. High-altitude ammonia ice clouds could reflect more sunlight and make the planet appear brighter. For a moment, the situation seemed manageable. The stripe had not disappeared, it was just hidden. But that explanation only worked until infrared observations started arriving. Thermal imaging showed something far more disturbing. The entire atmospheric structure underneath had changed temperature distribution in ways nobody expected. The region where the South Equatorial Belt existed was cooling. Vertical circulation patterns appeared weakened. Rising warm gases that normally pushed darker compounds upward had nearly stopped. That meant the stripe was not merely covered. The atmospheric engine driving its existence had partially collapsed. And now the problem became much larger than one missing stripe. Because if Jupiter's largest visible systems could shut down this quickly, then astronomers had misunderstood how gas giant atmospheres actually functioned. These were not stable planetary structures. They were temporary expressions of deeper cycles operating far below visible cloud layers. The image everyone trusted, that familiar striped giant hanging in textbooks for decades, suddenly became unreliable evidence. Jupiter had not changed appearance. It had exposed a hidden instability scientists never knew existed. Then things became even stranger. Months later, without warning, bright plumes began erupting through the pale zone. Massive thermal towers punched upward from deep inside the atmosphere. Each eruption rose miles above surrounding cloud layers. The dormant circulation system had reactivated violently. Dark material began spreading outward across the planet like spilled ink. Within weeks, the missing stripe started rebuilding itself exactly where it had vanished. The same visual anchor returned. Jupiter looked normal again. But now, normal meant something completely different. That side-by-side image of Jupiter, one version with its dark belt erased, the other restored, had transformed from a curiosity into evidence of a much deeper failure. Scientists realized they had been observing surface patterns and assuming permanence where none existed. The giant atmospheric systems defining gas planets were not permanent structures at all. They were temporary weather expressions linked to unstable processes buried far below anything telescopes could directly observe. And that consequence extends far beyond Jupiter. Because every model used to understand gas giants, from Saturn to distant exoplanets orbiting other stars, depended on the assumption that visible atmospheric structures reflected long-term planetary stability. Jupiter proved that assumption could fail overnight. The planet did not lose a cloud band. Astronomy lost a trusted system. And the next time you see Jupiter's perfect striped surface, remember something uncomfortable. That planet is not stable. It only looks stable.